Good afternoon, everybody. Welcome to Evofound. My name is Neil Schrody, and today we're going to be taking a look at the Evofinder similarity scores and how these scores can be used in looking at the information you're using on your system. With the Evofinder similarity scores, we are looking at automatically generated numbers off of 3D profiles that we have of the samples at hand. The generated similarity score focuses on the region of interest for the samples that have been labeled, and it uses that region of interest compared to that of other samples. Now, in the case of the cartridge case, we're looking at items like the firing pin impression, the breech face, or the ejector mark. And they're singular marks, so it's a one-to-one correlation between those. When we get into the bullet side of things, we have land and groove impressions where there's multiples in most cases. And then we have to do a one-to-one correspondence between each combination of land or groove impression, plus we can also compare slippage marks between the two samples. Now, every time we run one of these auto-identifications to generate a similarity score, we're going to get a normalized output on a scale of 0 to 1 that represents how similar the two region of interests are between the samples, and give us that point-to-point comparison so we can see, in the case of land, what land 1 to land 1 is, or land 1 to land 2, and go through that whole sequence. But the similarity score itself is a single numerical value that represents that pattern-based recognition or match between the two samples that we're looking at. What does this mean to us? Well, if we're looking at this, we have a land engraved area of two samples sitting right next to each other. The software is going to look at these and is going to come up with a relationship between the two to try and see how similar are the two. What does this number mean in comparison? Well, let's give you an idea of the ones we're looking at. The software is going to generate a similarity value of about 0.57 in this case, 0.58. And that gives you an idea of the scale of 1 of what we're looking at in similarity between the samples. Now, a similarity of 1 means that they are perfectly identical in scan and comparison, region label, everything, but we never have two identical matches. Even if we scan the same bullet twice and label it twice, we never quite get them exactly perfect. So 0.5 in some cases is considered high. Some people don't think it's quite as high. But what are good examples? So here's an example of good traces that are going to give us higher similarity scores when we compare them to similar samples. And then this is one of the other factors. If we have poor traces are going to give us lower similarity scores based on just the sample that we're looking at. Now, the question that we end up coming to is, does this show us a match, and what similarity scores do we need? Well, that's always the question people have. What's a good similarity score to say that we have a probable match and we should look at these? And the answer to that typically is it depends. If we look at these two particular samples, which are relatively well marked, we can have high similarity scores, which give us good numbers. And in this match, we would have nice similarity scores. But if we have medium quality traces on the sample, the areas of region or the areas or regions that the software is looking at may not match as well, but we still get a similarity score result out of this. And then we can have samples that give us a low similarity score, but could still be from the same source, as these two are shown. Now, as I said, the similarity between two samples is going to give us one generated number. And that really doesn't do much for us other than tell us what the software calculated for that similarity. What we need to have an understanding of is what is the information we're going to be looking at. Now, if we take a number of samples from the same source and we run similarities on them, we're typically going to get a distribution of them where we have a nice generalized grouping of what they're going to look at. Or if we look at a larger number in the sampling, we can get a nice bell curve distribution of how these similarity scores are going to relate to each other. And how tight the peak on that is going to be relates to how well the markings, or should I say how repeatable are the markings from one sample to the next on the source for this particular set of samples. Now, if we're going to look at this on the other side of the coin, if we're comparing samples to non-matched samples, we're going to get a different distribution on our similarity scores. And it's going to fall lower on the curve because these samples are going to be, well, not anywhere near as similar. Now, what does this do for us? Well, if we put these two curves side by side, now we can actually see, how would these normally fall in representation? Now, if I have a sample that I'm trying to compare to the database in my system, I don't get this nice bell curve of seeing where the similar or matched samples fall into it. I basically get a point out of that, if there even is a match or a possible match within that set. And I'll commonly get a distribution of the similarity scores in my search results that gives me this nice peak distribution. But generally, this is the peak of known, or should I say non-matched samples to the sample under test. Now, that's nice that we have this distribution, and there may be a possible match, but then we have to consider what is the probability that one of the samples in there is a match to the sample under test. And if we look at this from a probability calculation, we can consider that where those two curves fall, the most likely position for a possible match would be at the leading edge of the curve, and theoretically we can calculate the probability of a match occurring based on one sample's position with respect to the distribution of these similarity values. In fact, we can also look to see what the probability that it's in the first place on the list or that it would fall in the top 10. But we don't want to be running these nice equations for every time we run a sample and have to do math with that. What we want is we want the software to take the similarity scores of the search that we run within our system and then give us a display of where do these similarities fall, and then do this probability calculation based off the distribution of the non-matched samples, that large peak on the left, and give us an indication of possible match in the system. Now, if we do look at this, as I said, the left is going to be our non-matched histogram. And apparently some of my software decided to pop up and get in the way here. So there's my non-matched curve in the histogram. Moving forward, we have points that fall outside of this general distribution, which are potential hits within the system. Now, the Evofinder software is looking at the distribution of non-matched distribution, and is going to calculate, based on the position of similarity of these potential hits, to give us a non-matched probability, or a rarity. And what it's going to be saying is that, based on the color indication, we're looking at the probability that those points fall into the distribution of non-matched samples, which is the peak to the left. And if you look at the scale that we have on these for color indication, our lowest indication in this case gets into a 1 in 10,000 likelihood. And this is not going to be telling you that there's a 1 in 10,000 chance that these samples are identical based on the striations. It's based on the similarity scores generated by the system and the distribution of those similarity scores on the histogram. So we get a nice visual representation of potential hits that we should look at to see if there actually is correlation between the two samples. What you really want to see is typically that one sample that's going to stand out in your distribution. Now, they don't always come out like this, but this is sort of an ideal of what we're trying to get to. Can we get that one sample from the known matched set to stand out from the known non-matched or the non-matched distribution of samples that we're searching against? And what is going to be that interval between that outlier from the distribution? Does this mean you're going to see this every time? No. A lot of factors are going to come into this. How different are the samples between matched and non-matched? Those two curves that we looked at before, how separate are they, and where does that one sample lie within the distribution of the matched samples from the non-matched? But overall, the similarity score is going to give us that individual value that we can compare to a similarity score of every other number that comes out of the search function, and then look at it on our histogram to see, is there indication of likelihood of probable match in these samples? And then one of the other things that the software is going to do is, as we see that organized list ranking our most similar to our least similar samples, as on that small table on the right, if we do have that rarity or confidence that we have a is not part of the non-matched distribution, that color flag is also going to show up in our ranked list to give us a flag on the similarity to indicate that it's a possible match. And then we come back to, what does this do for us? Well, then we can actually take those samples and load them into our viewer and do a direct comparison of these samples to say, hey, do I have a match? Do I not have a match? For no conclusion in this case. So we can go on and use that information of what the Evofinder has provided us on these similarities and hopefully come to the results that we need to continue with the processing of samples. So that was a quick overview of the Evofinder system. I wanted to just check and see if there's any questions for people during this meeting to see if there's anything I can answer. And at the same time, I also want to make it a point to say that if there are other topics that people want to see, please put this into the comments or send us an email to let us know. We're happy to make sure that we're getting topics of things that you want to listen to. And then based on that, also I'm seeing no questions coming in through the system. Next time we're going to be back in 3 weeks after the holidays, after July 7th, and we're going to be talking about virtual comparison microscopy of the samples that we've been able to look at in the system. So this is taking the results of our search, finding those outliers that we want to look at, and then being able to visually look at them using the Evofinder software. I'd like to thank you all for your time today. It was a pleasure doing this presentation, and we look forward to seeing you next time. Thank you again.